So chapter 10, section 1 is the matrix and systems of equation. Yesterday we talked about how to solve the systems of equation using Gauss-Jordan. We started with a 2-variable, we did an example of 3-variable, and we left off here with example 6. So the first thing we have to do when we're solving using a systems of equation is to do what? Rewrite this in matrix form. So this is 1, -1, 1, 4. 1, 3, -2, -3, 3, 2, 2, 6. We talked about if 1 is in the top left corner and it's easy to get, this makes the rest a little bit easier. If it wasn't there already, let's say, for example, it said 3, 2, 2, 6, 1, 3, -2, -3, and 1, 1, -1, 1, 4. Like, let's say it started this way, then I would recommend step 1 being to switch. Either switch row 2 with row 1 or switch 3 with row 1, but get that 1 in the top corner. That's much easier than doing a third all the way across, right? A third all the way across means you have to work with fractions every time you use row 1, which I would strongly say do not do that. Okay, so the 1 is in the top corner. So then I said the next step I would recommend is working down to get the 0 underneath it. What's one way I could do that? Good. -1, row 1 plus row 2. So I'm going to multiply all of row 1 by -1. So -1, 1, -1, -4. And then row 2, 1, 3, -2, -3. You could have also done -1 times row 2 and added it to row 1. It would still give you a 0 in that row. It would have different numbers next to it, but the 0 would still be there. So 0, 4, -3, -7. And that can replace row 1 or row 2. Row 2 is what we were trying to replace. So I'm going to rewrite row 1. Change the new row 2. And then rewrite row 3. So I've seen, like, work-wise, I've seen people do this a lot of different ways. One way is to do what you're going to do the steps on the left, like the work on the left, and always rewrite on the right, okay, which is totally fine. You want to make it as organized as possible for you. Or you could do it in different colors. Like, I don't care how you show the work. Obviously, you just need to show that work. All right, now I want to get a 0 where the 3 is. How do I do that? Good. -3, row 1 plus row 3. So I'm going to do -3 times the top row. -3, +3, -3, -12, plus 3, 2, 2, 6. And I get 0, 5, -1, -6. 1 stays the same. 2 stays the same. 3 gets updated. Now I want a 0 where the 5 is. I also want to get a 0 where the 1 is and a 0 where the 3 is. So in the next couple of steps, order can be done completely different, okay? If that pattern, so right now, in order to get a 0 in this spot, you'd have to do what? To get a 0 there but not lose the 0 on the front. I can't use row 1 or I lose this 0. So you can get a 1 there and then multiply by -5, or what's another option? Can I multiply 2 rows and then add them? So I could change both of these, right? I could multiply row 2 by -5 and row 3 by +4, or negative vice versa. And then I'll get a 0 where that is, okay? Or if it's easier to go to the 0 where the -1 is, the order there doesn't matter. What you do not want to do is get this 1 before this 0 if that 1 is not easy. So if I can multiply by 1/4 and not have fractions, then I would recommend it there. But then I'm going to have a 3/4 and a 7/4, and I don't want to deal with fractions until I absolutely have to, right? So I would say avoid that. Don't get this 1 before you get this 0, or you're going to have to deal with fractions. Does that make sense? Yeah. Okay. So 2 choices. Change both rows and cancel out the 5, or go to the 3, like go to this spot multiply by negative 3, and cancel out the zeros at the end. Which one do you want to do? Both rows. Okay, so we're going to do negative 5, row 2, plus 4, row 3. So negative 5 times row 2 would be 0, negative 20, positive 15, 35. And then positive 4 times row 3, 0, 20, negative 4, negative 24. And I get 0, 0, 11, and 11. Now, before I rewrite everything all over again, I want to get this 11 to be a 1. How do I do that? Good. Multiply by 1/11 or divide by 11. So that's going to be that's my new row 3. 0, 0, 1, 1. Row 2 was 0, 4, negative 3, negative 7. Row 1, 1, negative 1, 1, 4. So I already know my z, which is what? 1. So if you know it's a whole number going into it, and I'd let you know if it was all whole numbers, like this one should be all whole numbers, then at least I already know that check. Okay? If z was something super weird like 17 over 3, then something's wrong. All right, so now I want to get a 0 here. What's the easiest way to do that without losing the 0 at the front? Good. 3, row 3, plus row 2. I'd get 0, 0, 3, 3, 0, 4, negative 3, negative 7. 0, 4, 0, negative 4. And I want that 4 to be a 1, so I could do what? Multiply by a 4th. So row 1 stays 1, negative 1, 1, 4. Row 2 becomes 0, 1, 0, negative 1. Row 3, 0, 0, 1, 1. So now I've got my y is negative 1 and my z is positive 1. I need to get a 0 here. How does that happen? Good. Have to use row 3 with that one, right? Because there's nothing I'm going to be able to multiply row 2 that's going to cancel it out. So I don't want to cover up there. So I'm going to do negative 1, row 3 plus row 1. 0, 0, negative 1, negative 1, 1, negative 1, 1, 4. I get 1, negative 1, 0, 3. That replaces row 1. And my last 0 has to go there, which means I have to use what 2 rows? Good. Row 1 and row 2, otherwise I lose the 1 at the front. So I'm going to, no, otherwise there's nothing to cancel with. So I can just add those two. Row 1 plus row 2. 1, negative 1, 0, 3, 0, 1, 0, negative 1, and I get 1, 0, 0, 2. So my final matrix is 1, 0, 0, 2, 0, 1, 0, negative 1, 0, 0, 1, 1. And my answer is? Good. Questions? So in addition, obviously, to the homework on this, there's 2 examples, and you can practice other versions. There's also, if you go back to the 9-3 homework, any of those questions that had 3 variables and 3 equations, you can resolve now this method. I would say find the ones that have whole numbers, make your life a little bit easier, work on those, okay? It's not to say fractions can't exist, but usually we try to make it a little bit easier on these, so at least you know if you're on the right track when you get to that last one. Yeah. So 10-2 is operations with matrices. In this section, you're going to learn the easy stuff of matrices, which is adding, subtracting, and using a scalar multiple. Those are super easy with matrices. And then a process that's a little bit more complicated, but nowhere near as complicated as Gauss-Jordan, which is multiplying two matrices. So the first thing is that if you're adding and subtracting matrices, you can only do this if they have the same dimensions. So you can only add a 2 by 3 to a 2 by 3. I can only add a 2 by 2 to a 2 by 2. I can only add a 3 by 1 to a 3 by 1. They have to have the same dimensions. And then all you do is literally add the first spot in each, the second one in each, the third one in each. So that if it was 1, 2, 3, 4, plus, did you find it? 5, 6, 7, 8. So I can add these because they have the same dimensions. They're both 2 by 2s. So what I do is literally add row 1, column 1 in each one. So 1 plus 5 would be 6. And then I add row 1, column 2. 2 plus 6 would be 8. And then I'd add row 2, column 1. 3 plus 7 would be 10. And then I'd add row 2, column 2, which is 4 and 8. And that's 12. So you're literally just adding the corresponding cells. If you find yourself struggling to like figure, because the more rows and columns these have, like you could totally separate them out so that you know which column and row you're looking at. This is, to me, like easy to highlight if you want to do that kind of stuff, especially when we get into multiplying, it gets a little bit more complicated. So the instructions will just say perform the indicated operation, and it's either going to give you something like this or you'll see a change in instructions in just a second. But these are your two matrices. The first thing you want to ask yourself is, can I do it before you even start? Can I add a 2 by 2 to a 2 by 2? Yes. So I would get negative 1 plus 1, which is 0. 2 plus 3, which is 5. 0 plus negative 1, which is negative 1. And then 1 plus 2, which is 3. That's it. Easy stuff, right? Way better than yesterday. Huh? For adding and subtracting, that's as hard as it gets. Yeah. I mean, sometimes you have to multiply and then add and subtract, which you'll see in a second, but it doesn't get much more difficult than this. I would say the mistakes that come from this are the minus the negatives. Like if this was a minus and you go to do this one, people tend to mess that up. The minus the negative becomes a plus, right? It's just the same rules as adding and subtracting, but people tend to make that mistake. All right, so then I look at the next one. That first matrix has the dimensions that's a 2 by 3, and the second one has a 2 by 3. So I can do it. So then I add 0 plus 3 is 3, 1 plus 4 is 5, negative 2 plus negative 1 is negative 3, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 0 is 3. If you forget like to check to see if you can do it first and you start adding and one has like 2 rows or 2 columns and the other one has 3, obviously there's not going to be something there to add or subtract to it. So it should be kind of like a little red flag that you're doing something wrong. So look at 3. Can I add these? No. This is a 3 by 1, and it's important to understand dimensions because we're going to use it when we do multiplication. And this is a 1 by 3. So this cannot be done. I think it says put the word impossible in. Yeah, I think that's the instruction says impossible. If it asks for y, you would say they have different dimensions. Still good? Yes. All right, so then the scalar multiple is just a number that's being multiplied by a matrix. So when you have a number that's being multiplied by a matrix, you literally distribute that number into every single cell in that matrix. So it would be something like 3, and then you'd have your matrix, and everything that's in this matrix gets multiplied by 3. That's a scalar multiple. That can be done to anything because it doesn't matter the dimensions. So this is how else you would see the instructions for adding, subtracting, and then the scalar multiple. So the first one says find 3a. At the top, it gives you both matrix A and matrix B. So 3a means I'm taking this matrix, 2, 2, 4, negative 3, 0, negative 1, 2, 1, 2, and I'm multiplying everything in there by 3. So 3 times 2 is 6, 3 times 2 is 6, 3 times 4 is 12, 3 times negative 3 is negative 9, 3 times 0 is 0, 3 times negative 1 is negative 3, 3 times 2 is 6, 3 times 1 is 3, and 3 times 2 is 6. So You're just multiplying it in. 5 says what? Negative b. So the negative just means what on the b? Take it, multiply everything by negative 1 or change all the signs. So this becomes negative 2, 0, 0, negative 1, 4, negative 3, 1, negative 3, negative 2. Still good. Okay, then 6 I would say is as complicated as adding and scalar get. So this says 3a minus b. So I have to first take 3a, which we've already done, so we don't have to redo that work. I have to take 3a, which is this one, and minus b. So I could either take 3a and add it to the negative b we've already done, or I'm going to show you the other way just because I want to walk through that process. If I didn't already have 3a, I would have done 3a, but I do have it. 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6. And then I'm going to subtract from it b. And then again, for as like smart as you guys are, the negatives tend to get you, especially the minus the negative. So be careful here. You have two options. One is distribute in the negative and then change the sign between it to plus, or just carefully go cell by cell. So 6 minus 2 gives you 4. 6 minus 0 would be 6. 12 minus 0 would be 12. Go to the next row. Negative 9 minus 1 would be negative 8. 0 minus negative 4 would be negative 4. 0 minus 3 would be negative 3. Go to the last row. 6 minus a negative 1 becomes 6 plus 1 or 7. 3 minus 3 is 0. And 6 minus 2 is 4. Did I do something wrong? I did it totally to prove a point that it's so easy to make a mistake. You're welcome. See how easy it is to mess up your signs? Thank you. Which one? Negative 9 minus 1 is negative 10. Just make sure you paid attention.
Wait, is it
Negative 3 minus 3 is negative 6. I just messed up that whole row. Yeah, good job. Questions? Easy stuff. Yes? Way better. So multiplication is not a difficult process. It's tedious and it's weird. I'll give you that. But it's nothing like the length of what yesterday's was. So multiplication has different rules. Okay? When we multiply matrices, you're not literally like multiplying the first one and the first one and then replacing it. It's very different. So what you do is, the first thing is check to see if you can multiply two together, and the rules are different. You can only multiply two matrices together if the outer two numbers, or the inner two numbers are the same. So if I write out my dimensions and I say 2 by 3 and 3 by 2, I could not add these because they don't have the same dimensions, but I can multiply them because the middle two numbers are the same. So we check for the middle numbers, and then the outer two numbers are actually the dimensions of your answer. And I'll show you why that's important in a second. So if I had a 2 by 3 and a 3 by 1, could I multiply these together? Yes, because the inner two match, and then the outer two are the dimensions of your matrix. So 2 by 1 means it's going to be 2 rows, but only one column. So if I had a 2 by 3 and a 3 by 2, it's a yes because the 3's match. And the outer two tells me it's going to be a 2 by 2, which means I can set it up like that. If it was a 3 by 3 and a 3 by 3, it's a yes because the middle match. The outer two would be a 3 by 3. So I set up an empty grid, like a tic-tac-toe board. And then we're going to figure out how to fill in each of those squares, okay? But that's the beginning. You can't even get to the multiplying until you make sure you understand that. So middle two have to match. Outer two are your result, okay? Then each cell, so each spot, gets filled by the product of its name. So if this first cell is called row 1, column 1, because it's in the first row and it's in the first column, then row 1 from the first matrix gets multiplied by the column 1 from the second matrix. So the name of the cell tells you what you're multiplying together. So then whatever numbers are here, I'm going to multiply the first term here, A times this term. So if it was like 1 times 2, that would be 2. And then I add it to the second and the second. So the first row, first column gets multiplied by the first row, first column. And then the first row, second column gets multiplied by the second row, first column. So you go across and down if you're going left to right, across and down, okay? So if I were just to randomly say, I want to fill this spot right there, what's the name of that spot? Row 2, column 2. So if I had 1, 2, 3, 4, 5, 6, and then I had 7, 8, there would be another one here, 7, 8, 9. 1, 2, 3, 4, 5, 6. Let's say I'm multiplying these and I'm keeping them all positive for now, okay? If I just wanted to fill that individual cell, I would go row 2, column 2. And then I multiply them in pairs and then add them together at the end. So this would be a 4 times 1, because it's 1, first and first. Then plus 5 times 2. Then plus 6 times 3. And then I would do 4 plus 10 plus 18, or 14 plus 18, which is 32. So each cell tells you which ones you're multiplying together. The first term tells you which one you're picking from the left one. The second one tells you what you're picking from the right one. And order is important here. So AB is different than BA. So again, you're going across and down each time. All right, so let's practice this. The directions literally say multiply A times B. And again, that's important because it's different for B times A. So that tells me I'm looking at A and B. I'm figuring out their dimensions. What's the dimensions of A? 3 by 2. How about B? 2 by 2. Can I multiply these? Yes, middle two match. My result is a 3 by 2. So this has 3 rows and 2 columns. So as you get better than this, you may not need to do every single step I'm about to do, but we're going to practice it in the beginning. I'm going to name each cell. So the first one is row 1, column 1. Row 1, column 1 means multiply row 1 from A and column 1 from B. So always across and then down. So I would do -1 times -3 plus 3 times -4. And I get 3 minus 12, which is -9. My next cell name is row 1, column 2. So I still use row 1 from the first one. This is when notability really pays off, because just wait till you get to having to do this in pencil. I'm still doing row 1 from the first one, but now I'm doing column 2 from B. So I'd get -1 times 2 plus 3 times 1. -2 plus 3, which is 1. Still good? What's the next cell's name? Row 2, column 1. So now I'm on to row 2 over here. Row 2, column 1 would be 4 times -3 plus -2 times -4. And I get -12 plus 8, which is -4. Then I'm in row 2, column 2. So row 2 still on the left, but column 2 on the right. 4 times 2 plus -2 times 1. 8 minus 2, which is 6. Now I move into row 3, column 1. So row 3, column 1, 5 times negative 3 plus 0 times negative 4, negative 15 plus 0, which is negative 15. And then row 3, column 2, is 5 times 2 plus 0 times 1. So then you just want to, like on WebAssign, it will just give you those individual cells. If this was a quiz or a test, you just rewrite those neat for me so that all that mess is not there. And that would be the multiplication or the product of those two. Questions on that one? All right, go to 8. First of all, can you do it? What are the dimensions of A? 2 by 3. And the dimensions of B? 3 by 2. So can it be done? Yes. What are the results? 2 by 2. All right, so we know our result is going to be a 2 by 2. The first one is row 1, column 1. So row 1, column 1. This time they each have 3, so we're adding 3 products. 1 times negative 2, which is negative 2, plus 0 times 1, which is 0, plus 3 times negative 1, which is negative 3, and I get negative 5. Then I go row 1 and column 2. So 1 times 4 is 4, plus 0 times 0 is 4, plus 0 times 0 is 0, plus 3 times 1 is 3, and I get 7. And then I go to the next one, which would be row 2, column 1. So row 2, column 1, and I get 2 times negative 2, which is negative 4, negative 1 times 1, which is negative 1, negative 2 times negative 1, which is positive 2, negative 5 plus 2 are negative 3, and then row 2, column 2, and I get 2 times 4, which is 8, plus negative 1 times 0, which is 0, plus negative 2 times 1, which is negative 2, and I get 6. So negative 5, 7, negative 3, and 6. I mean, with a graphing utility, yeah, but not any other way, like arithmetically, no. So then we'll save the rest of the examples for tomorrow, but I will show you that, like, if you had so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Let's say I'm going to multiply these out. What's the dimensions of the first one? 2 by 3. The second one? 2 by 3. Can this be done? No. So I can add these, I can subtract these, but I cannot multiply because they don't match up, okay? If you, for some reason, don't understand that, right, and you take this row and this column and you try to multiply it out, you're going to run out of terms on one of them. So you've got 1 times 7, which makes sense, 2 times 1, that makes sense, but then you have nothing to multiply by 3. So that you will run out of cells at some point that are going to line up. So hopefully you can catch it. But in this case, if it was like that, you would again just write that that's impossible. It cannot be done. Questions for me?